All right, so we're on part two. After like evaluating how people performed on the test last year and things like that, I realized that there was more stuff that was needed in the notes. Does that make sense? So I redid the notes, but however, when I made your copies, I reprinted last year's notes, even though I changed them. I don't know how, I don't know what was going on. Really couldn't tell you. But so this is why I was telling you that we had to white stuff out because I drastically changed your example one. Does that make sense? As you can see, your example one is drastically changed. God. Yes. So that's what I was trying to tell y'all to white out that function or just like draw a box around it. I don't know how finicky you are about it, but essentially, we need to talk about absolute value functions. Okay. Do you guys remember absolute value functions from algebra one? Do y'all remember a function that was a V shape? Made a V? Yeah, you do. Yeah, you do. It was absolute value. We're going to remember, we're going to recall. So for absolute value function, I'm going to give you a moment to write down. But what we need to know as far as a class is that our A is the slope of the right side. Okay. So the A is the slope of the right side of our absolute value function. Yes. You're going to write this down. H is our horizontal translation. So it's telling us how our function is moving across the x-axis. Okay. K is the vertical translation, and it's telling us how we're going up and down. And put together, they make our vertex, which is H and K. All right. I'm going to give y'all a moment to write this down, and then we're going to go through graphing the parent function and defining it as a piecewise defined function. Cool? All right. Got it? So a piecewise defined function means that we have multiple intervals, correct? In algebra one, you guys learned about absolute value functions, even though you say you didn't. I'm gonna be, hopeful that it came up. Okay, the absolute value function is what we call our V function. Okay, remember that absolute value is asking you how far is a number from zero, correct? So how far is a number from zero means that value is going to always be positive. So no matter what it is, it's going to always come out to be a positive. So for our parent function, we're going to start off with, we're just going to use the basic values. We're going to use -3, -2, -1, 0, 1, and 2, and 3. So when I ask you, how far is -3 from 0? It's 3 units, right? How far is -2 from 0? 2 units. How far is -1 from 0? 1 unit. How far is 0? 0. And then 1, 2, and 3. That is all absolute value function is asking you. How far is this number from 0? Okay. So when you plot these points, you end up with what I asked earlier, the V shape. So you have -3, -2, -1, 0, 1, 2, 3. And for me to attempt to draw the world's straightest line, I'm going to have to put all the dots in place because if I don't, you know what happens. Yep. I touched all those points. It was terrible. I thought they were going to help me be great. Concentrating. I'm convinced that something's wrong with my computer and my board this year because I promise y'all, I did not write this terrible on here. I don't know. All right, y'all now remember seeing this shape? Y'all remember absolute value? Okay. So this was our absolute value function. Okay. When you look at the absolute value function, notice that it is two different slopes, right? You have a positive slope on the right side and you have a negative slope on the left, right? So we have a positive slope here and we have negative slope here. And this split happens at our vertex. Okay? This lets us know that our absolute value function can also be defined as a piecewise defined function, correct? So we could say, okay, as I'm going forever to the left or forever to the right, this is what the function is doing, correct? So when we write our piecewise function model, our piecewise function looks like this. F of x equals, okay? On the left side of our polynomial function, what is the slope? Rise over run. I go up one, left one, up one, left one. So that is a negative x, correct? So my slope is negative. So it'll be negative x. So I'm negative x for when x values are less than or equal to 0. Does that make sense? Okay. On the right side, I have a positive slope. And this is for when things are greater than 0. Notice I didn't say equal to because I've already defined 0 on the first interval. And we talked about in our first lesson that if it's already defined on one interval, on the next interval, it cannot be. Otherwise, it's not a function, right? X's do not repeat. So this is where absolute value functions and piecewise functions come together. Okay? You can take an absolute value function and you can write it as a piecewise defined function. And if you see that a piecewise defined function has opposite slopes, you can also write it as a, well, not just opposite reciprocal slopes. You can write it as a absolute value function and vice versa. Okay? So let's look at one together. Are you ready? Did y'all remember on example 2, did you guys get rid of stuff? Okay, good. All right, this is what your example 2 should have been. I know. I'm gonna do better next year. Every year we grow and we learn. See, look, mistakes help me learn. I'm still learning. I'll keep trying. Food for our brain. Okay, so everyone has their pieces written down? All right, so let's analyze what's given to us. So we have f of x equals the absolute value of x minus 1 plus 5. So we're going to identify our a, our h, and our k. So what is our a here? So when I don't see a number, who's there? 1. Casper the friendly 1. So notice that there is no number there. So it's Casper the friendly 1. Okay, your h. For your h, remember x's are liars. X's lie. So even though it looks like a negative 1, it's actually a positive 1. Okay, and your k is 5. What this all together tells you is you now have your vertex. So your vertex is at 1, 5. And you have the slope of your right side. Okay, so I'm going to go to 1, 5. So we go to 1, we're going to go up to 5. And on the right side of 1, our slope is 1, which means we're going to rise 1, run 1, right? Rise over run, rise, run, rise, run, rise, run, rise, run. Does that make sense? Okay. In order to get the other side of the V, you have to do the opposite reciprocal of that, right? So instead of me rising and running to the right, I'm going to rise and run to the left. If I went the other direction, would I make a V? You would. If you went the other direction, no, you'd just be making a line, right? So when you're doing it, or sideways, or a Pac-Man, you'd be making a line or a Pac-Man, depending on which way you went. So now I'm going to do the opposite on the left side. So I rise, run, rise, run, raise, run. And bam, I have now graphed. Yep. She did it. Yep. I've now graphed my absolute value function. So this is f of x as absolute value. Was that terrible? Because we already know how to find the vertex and we already know what slope means, right? Rise over run, correct? All right, so now we're gonna do it as a piecewise. So your piecewise is saying, as you're going forever to the left and forever to the right of this absolute value function, what is happening? So we're gonna write it as, we're gonna call our piecewise, let's call it g of x. G of x equals. So we're gonna draw our little, that's the best brace I can draw. Yep. Oh, pretend y'all don't hear a song in the background. We're gonna keep going. All right, so on the left side, what is our slope on the left? What was our slope? What kind of one? -1. So it has to be negative x. And remember, in order to write a linear equation, you need that slope and y-intercept, right? Well, where's my y-intercept? At 6. So it's negative x plus 6. And this is for when x's are to the left of what? 1. So less than or equal to 1. Because 1 is the x value of our vertex, correct? All right, so now we're going to do the right side. So on the right side, what is our slope? 1, positive 1. Now, this time we didn't go, but what you can easily figure out what your y-intercept is, right? If I was to continue going down and over 1, where would I end up hitting? 4. So my y-intercept would be at 4. So it'll be plus 4. And this is for when x values are going forever to the right. So these two things represent the exact same thing. How we feel? Semi, all right? Okay. If you have your computer out, please go to Desmos. Because our last part is graphing with technology. Okay. So our example 3, remember I told you our example 3 was good to go? We didn't need to change that. We're going to put in our intervals for where things are taking place. And we're going to learn how to do this using Desmos, okay? So using Desmos, it's not like it's difficult, but you do have to be comfortable with writing. Does that make sense? Okay. So let's go to Desmos. Oh, I should have just clicked on our little homepage. Please take me to Desmos. Here she is. Yep. All right. So here in our Desmos, so we in our notes we have f of x equals x plus 1 if x is greater than or equal to -7 but less than 2. We have it -7 if x equals 2, and we have negative x plus 2 if x is greater than 2. Okay. And so our job here is to be able to put this into our handy dandy calculator. So the first thing we're going to do is type in our first piece, which is y equals x plus 1. After we type in our first piece, we're going to use our brace. So you're going to hit shift brace, and you're going to put in that interval. So we're going to put in -7 less than equal to x less than 2. Close brace. Okay. In order to get those symbols, all you're doing is pressing the greater than or equal to symbols at the bottom, and then pressing equal if you need it. And it should make the equal to symbol. Still with me? Okay. Now we're going to do our next piece. So that's the first piece. What was our next piece? Our next piece is -7. So we have y equals -7. And this is for when? Only when x equals 2. Supposed to draw a little dot. They're probably on the other side. Oh my gosh, guys. Why didn't anyone tell me my hair looked crazy? I just took my bonnet off and came to work. I just now saw myself in this mirror in front of me. Y'all are so kind. I'm in the middle of teaching. For what? Oh, if so, I don't know where they would be, but yes, I'd have to look. All right. I don't know why the X one didn't work, but it's supposed to just put a little dot at 2, -7. Do y'all see it? I do not. See, it says that it's there, that it's defined, but it's not showing us it. Like, I don't see a dot here. Okay, we're gonna come back to that one. That was weird. All right, let's try the next one. Y equals -x plus 10. And this is from when x is greater than 2. Okay, well, that one worked. But I wonder why the dot's not there. Oh, guys, because we were looking at the top. It's -7. Slow moment down here. Oh, it's still not. Okay. I was being hopeful. It says it's there. There. I just turned on the table. Okay. I see what you're doing the Desmos. So again, this is my first year teaching the Desmos piece of this. How do you feel about it? Is it doable? Huh? Like, do you feel comfortable? Because you already know how to do it by hand. So in part one, we learned how to do it by hand, right? Part two was to learn how to use technology. How do you feel about the technology? Yeah. So now you have your points. So now you've put it in. So then when you're graphing on your paper, you can open your table and you have the points that you can graph on. Does that make sense? So now I know that I can plot draw my lines, right? And it'll do it for you. It goes all the way. If you need -7, what would you type in? -7. It'll tell you at -7 you should be at -6, and then you plot those points to your paper. Make sense? Okay. Then the same thing here. We would go to this one. It tells us where we could go, and everything is undefined, undefined, except at to -7. That means it's just a single dot, right? And then we keep going, and then on the next one, turn on our table. It is undefined, 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 undefined until we get where? To the other value. So this starts at 2. So when I start here, it's not 2 because 2 is only equal here. I would have to put in values that I can graph. So I can graph 3, I can graph 4, I can graph 5, I can graph 6, I can graph 7. Do you get where I'm going? Okay. I show you the technology as an aid, but we already know how to do it without it. Does that make sense? Okay. Questions about using the technology. So essentially, you would recreate this on your notes or in your paper or whatever. And so these are your points that you could use to help you find, identify. You can kind of see where it starts. Yeah, you're plotting it in your notes. You're creating the graph. You're creating this one, the dot, this one. All right, so I'm going to go back to my graph because I can't do both. So I'm going to show my graph. So we were at -7. Was it -7.6, right? There's a little hole there. So here's my first interval from our, then I'm going to do my next one. That was the blue dot. And it was at 2, -7. It was just a point. And then I'm going to do my last interval. And we were at 2. It's a open circle at 2, 8. And then we're going down, down, oh, down. Oh. This one is an arrow going forever. Okay. How do you feel about the Desmos? Doable? Okay. So recapping in Desmos, when you're writing this, you have to make sure that each one is a y equals, right? And then you're going to be putting in your intervals, but you have to use braces. And I know those are ugly braces, but you get what I'm saying. I can't make tiny ones. I could barely make big ones. Oh, that's just worse. That's good. There you go. Oh, I don't know why this is so difficult. You get it. The braces, the intervals go in the braces. Okay. Questions, comments about Desmos? No? Mm-mm. It's only the first one to open, only your lower bound because it says strictly, right? Everything else is defined. And that's how you, if you look at the table, everything after 2 was defined, right? All right. I feel like I did exactly that. Mine looks exactly like that. And if you don't agree, you're a hater. So, yep, I said what I said. Bam. All right. Part 2. Done. Yay.